Hello, good morning students. Welcome back your chemistry class. So as we know that in the last online class we start your chapter hydrogen, and the online session will be covered your preparation for hydrogen. How will you prepare dihydrogen according to the laboratory method, according to the commercial or we as well as manufactured. Okay, so today we'll be continue with the preparation of dihydrogen as a commercial and industrial. Okay, so here we discuss your 2 points by the electrolysis process and from synthesis gas. Okay, so next is third point under these, that is from hydrocarbons. Okay, how will you prepare dihydrogen by the hydrocarbons? Hydrocarbon are those when your carbon is bonded with the hydrogen. That means ki all the compounds that present your carbon and hydrogen, that we called as hydrocarbons. Okay, so here from hydrocarbons, first method under is your, that is partial oxidation of hydrocarbon. That means ki here the oxidation of hydrocarbon, a mixture of hydrocarbon, okay, that is mixed with the steam and is passed over the heated with nickel catalyst at 1270 Kelvin of temperature. Okay, so here naphtha, that is also the form of hydrocarbon, that is like alkane, and this is your, take you example, that is natural gas. So here natural gas be used for making a synthesis gas as well your hydrogen dihydrogen gas. Okay, so here natural gas is your methane, that is your heated in the presence of nickel catalyst. Temperature is 1270 Kelvin, and here water is used in the form of steam. So overall reactions to be converted into the product, that is your synthesis gas, that is your carbon monoxide plus 3 hydrogen. Okay, so this is the preparation for partial oxidation of hydrocarbon, and the whole process of obtaining H2 from natural gas is called steam reforming process. Okay, so in the question we asking ki how will you prepare the steam reforming process, they given the different option. So remember that when we obtain from a natural gas, okay, they obtain a dihydrogen by the natural gas in the presence of nickel catalyst and temperature, this condition. Okay, next is your thermal cracking or natural gas. Thermal cracking of natural gas. So here thermal cracking is what, here the dihydrogen also be obtained by thermal cracking of natural gas. That means ki simply be heated your natural gas like this hydrocarbon CH4, not be here the use of water in the form of steam, here only the use of natural gas as catalyst nickel with the same temperature 1270 Kelvin, and it's convert into carbon plus dihydrogen. Okay students, so here fourth points under the manufacturing of dihydrogen. So the name of process is Lean process. That is a Lean process. Under this the reaction is proceed by oxidation and reduction stages, that is 2. So what happened in this process, where the dihydrogen can also be manufactured by passing alternate current. Okay, dihydrogen is manufactured by passing the alternate current of steam and water gas over red hot iron. Okay, that is will be prepared dihydrogen when we passes your alternate current of steam and water gas, that is over the red hot iron. Okay, so here oxidation stage. Okay, so oxidation stage, all you know that will be the addition of oxygen. So here iron is treated with water, it is the use of steam, that is water in the form. Okay, and the temperature is your 1023 to 1073 of Kelvin. Okay, so after that it convert into magnetic oxide. Okay, Fe3O4 plus hydrogen. Okay, similarly in case of reduction, so here reduction, removal of oxygen, so here magnetic oxide, okay, from this reaction is proceed into reversible reaction, and that is convert into iron plus here 4 water molecules. Okay, so in this reaction is what happened ki here the whole of iron has been be oxidized. Okay, that means ki here is the supply is the cut off as a stream of water gas, and it be passes after that to be reduced to magnetic oxide to iron. Okay, so similarly is here when we that is it reacted with carbon monoxide, and here is also be obtained from magnetic oxide to iron. Okay, so here this magnetic oxide yeah, Fe3O4 is reduced to iron. Okay students, so this is about the preparation of dihydrogen. Okay, next is the properties of dihydrogen. So here properties of dihydrogen is categorized into two ways. So all you know that is categorized into two physical and chemical properties. So under the physical properties about dihydrogen is what it is: colorless, tasteless and odorless gas. Okay, and it is the lightest substance, and it's slightly soluble in water, and its molecules are non-polar. Okay, because you have already learned about polar and non-polar molecules in the fourth chapter. Okay, and it can be liquefied. That means कि hydrogen gas can be liquefied when we apply the condition that is must be important: low temperature at high pressure. Okay, remember that liquefied gas of hydrogen under the condition low temperature and high pressure. Okay, next is a chemical properties. So chemical properties of dihydrogens to be large extent that is depend upon its bond dissociation enthalpy. Okay, so here chemical property of dihydrogen is totally based on the bond dissociation enthalpy, and all you know that what's the meaning for bond dissociation enthalpy: the amount of energy required to break a bond between the atoms, that we called as bond dissociation enthalpy. And here the bond dissociation enthalpy of dihydrogen is highest in a single bond between two atoms. Okay, so here chemical properties, first is a neutral character. That means ki it is neutral to a litmus solution. No change of color with anyone reacted with litmus blue and red. Combustibility, that combustion. Okay, so it is highly combustible gas and burn in air or dioxygen with the pale blue flame to form a water. Okay, so here what is happen, here it is highly combustible gas and burn in your air or in the presence of dioxygen with color of the flame is your blue and to form a water. Okay, so hydrogen is reacted with oxygens to form a water molecules. Okay, next is a reaction with metals. When the dihydrogen is reacted with strong electropositive metals like your sodium, potassium, calcium at high temperature to form salt like metal hydrides, that is your reactivity of dihydrogen. So I am already explained in your redox reaction chapter when the metal is your reacted with metal like your alkali metal, alkaline earth metal, these are the metals, but most of the group 1 element. Okay, that is reacted with hydrogens to make a metal hydrides, and here the oxidation state of hydrogen is your -1. So remember that when the hydrogen is reacted with alkali metals, so here the oxidation state of hydrogen is -1. So here for similarly like your that is sodium hydrides, and this is alkaline earth metal, so here the also we form as a calcium hydrides with a same temperature 573 Kelvin in both cases. Okay students, so next property, reaction with non-metals. So next activity, रिएक्शन विद नॉन मेटल, और प्रीवियस इज रिएक्टिविटी की रिएक्शन विद मेटल्स। ठीक है, तो हम स्टडी करेंगे कि हम यहाँ पे डाईहाइड्रोजन्स को रिएक्ट करवा रहे हैं विद नॉन मेटल्स के साथ। ठीक है, सो हियर डाईहाइड्रोजन कंबाइंस विद मैनी नॉन मेटल्स एट हाई टेम्परेचर इन द प्रेजेंस ऑफ कैटालिस्ट to form covalent or molecular hydrides. So under this reactivity what happen? Here the dihydrogen will be combined, means hydrogen dihydrogen combine करेगा किसके साथ? Non metals के साथ. Condition is what? High temperature and the presence of catalyst, and the formation is what? That is the formation of molecular hydrides as well as your covalent hydrides. So first reactivity with the dioxygen to form a water molecules. Okay, and reaction is your strongly exothermic due to the evolution of energy. Okay, next is your reactivity with halogens. So here halogen is combined with dihydrogens to form halogen halides. Halogen halides, halogen matlab halogen family of the member group, and halides for a hydrogen. Okay, so here hydrogen is reactive with halogens to form a halogen halides. ओके, रिएक्टिविटी ऑफ हैलोजन टूवर्ड्स डाईहाइड्रोजन, जो भी रिएक्टिविटी रहेगी हैलोजन किसकी तरफ? डाईहाइड्रोजन की तरफ, वो कैसी रहती है? इन द डिक्रीजिंग ऑर्डर ऑफ दिस पैटर्न. ओके, आपने याद रखना है यहाँ पे जो ऑर्डर ऑफ रिएक्टिविटी वो डिक्रीज रहेगा बिकॉज बेस्ड ऑन दियर इलेक्ट्रोनेगेटिविटी डिफरेंस. सो हियर हाइड्रोजन रिएक्ट विद फ्लोरीन इन डार्क कंडीशन, hydrogen react with chlorine in the sunlight, hydrogen is react with bromine in the catalyst, the temperature is 673 Kelvin, and here hydrogen is also react with catalyst platinum, that is temperature is 673 Kelvin, and to form a different products. Okay, next is your reactivity with dinitrogen. So when nitrogen is your reacted with dihydrogens to form a ammonia, and the name of process is your Haber process, that is most be important. And here the use of catalyst act as a iron, and here is your promoter, that is your molybdenum. Okay, temperature is your 673 and pressure is your 200 atmosphere. Okay, this is very important process, Haber process. Sometime direct ask the question in reaction, write the name of reaction, so write the reaction in your question paper and give the multiple option in by this name, Haber, Dalton, like this name, and to be choose the correct answer of this reaction. So this is the name for Haber process. Okay, sulfur, next is a reactivity with sulfur, so it form hydrogen sulfides. Okay, so when hydrogen is react with sulfur to form a hydrogen sulfide, that is H2S. Okay, next with carbon, so here when the reactivity of carbon with dihydrogen have some conditions. Okay, condition is what? That is temperature like your conditions, and to form a carbon hydrocarbons. Okay, like their paraffins and olefins. So here that is methane and that is your acetylene. Okay, next is your reduction of metal oxide and ions. Okay, reduction of metal oxide and ions. So here dihydrogen is act as reducing agent, because you have already learned in our previous chapter, because dihydrogen is act as a reducing agent and hence oxide is reduced to certain metal. Okay, that means कि कोई भी metal oxide है उसको वो reduce करता है in terms of metals के लिए. That's why we dihydrogen be called as reducing agent. Okay, so here be oxide is reduced to certain metal is your less electropositive metals than the zinc, such as your metal is reduced, that is your copper oxide, lead oxide, iron. Okay, these are the some example to be reduced from oxides to simple metal. Okay, an oxide of strongly electropositive metals such as alkali and alkaline earth metals are not reduced by this method. Okay, this is only based for a less electropositive than your zinc. that means कि जो zinc से less electropositive रहेंगे means कि below the hydrogen that can be reduced with the hydrogen. Okay. Next is your hydrogenation of unsaturated hydrocarbons. Hydrogenation of unsaturated hydrocarbons, such as here the hydrogenation, that means the addition of hydrogen in which unsaturated hydrocarbons. Unsaturated means your carbon is present with is carbon present is your double and triple bonds. Okay, that means ki hydrocarbon is your present in double and triple bond, that we call as unsaturated hydrocarbons. So unsaturated hydrocarbons such as your alkene and alkynes, that we added your dihydrogen in the presence of catalyst to be form a saturated hydrocarbons. Okay, so here we consider olefins, that is ethane and acetylene. Okay, so here we reacted in the presence of catalyst with particular temperature to convert ethene to ethane, acetylene to ethane. That means ki here double and triple bond is converted into single bond, that we call as a hydrogenation of unsaturated hydrocarbons. And here one example another with your olefins, that is hydroformylation. Hydroformylation under what is olefin is reacted. This is olefin reacted with carbon monoxide and hydrogen. Okay, so here olefin is reacted with hydrogen and carbon monoxide in the presence of catalyst, and here the catalyst is your di cobalt octacarbonyl. You can also be called as a octacarbonyl dicobalt. As a catalyst under the high temperature and pressure, it's convert into aldehydes. This is your aldehyde group. Okay, so this is the general reactions for when the olefin is converted into aldehyde groups. And the use of dihydrogen is here what, that is the used in the hydrogenation of vegetable oils to form a solid fat like a vanaspati ghee. It is a manufacture of bulk chemicals in the manufacture of hydrogen chlorides, and liquid hydrogen is used in the rocket fuels in the space research. Okay, so liquid hydrogen is prepared when the mixed with the liquid oxygen. Okay students, so this is about your dihydrogen for properties. Okay, I hope you all understand. In case of anyone students have related any reaction, any concept, any topic, then you can send me your problems on my WhatsApp number, so next time will be resolved in your class lecture. Okay, so thank you and have a nice day again.